Apollo 16. Apollo 16 was the 10th manned mission in the United States Apollo space program, the fifth and penultimate to land on the Moon and the first to land in the Lunar Highlands. The second of the so-called J missions, it was crewed by Commander John Young, Lunar Module pilot Charles Duke and Command Module pilot Ken Mattingly. Launched from the Kennedy Space Center in Florida at 12:54 PM EST on April 16, 1972, the mission lasted 11 days, 1 hour and 51 minutes, and concluded at 2:45 PM EST on April 27. Young and Duke spent 71 hours, just under 3 days on the lunar surface, during which they conducted 3 extravehicular activities or moonwalks, totaling 20 hours and 14 minutes. The pair drove the lunar roving vehicle, the second produced and used on the Moon, for 26.7 kilometers. On the surface, Young and Duke collected 95.8 kilograms of lunar samples for return to Earth, while Command Module pilot Ken Mattingly orbited in the Command and Service Module above to perform observations. Mattingly spent 126 hours and 64 revolutions in lunar orbit. After Young and Duke rejoined Mattingly in lunar orbit, the crew released a sub-satellite from the service module. During the return trip to Earth, Mattingly performed a 1-hour spacewalk to retrieve several film cassettes from the exterior of the service module. Apollo 16's landing spot in the Highlands was chosen to allow the astronauts to gather geologically older lunar material than the samples obtained in the first 4 landings, which were in or near lunar Maria. Samples from the Descartes Formation and the Cayley Formation disproved a hypothesis that the formations were volcanic in origin. Mattingly had originally been assigned to the prime crew of Apollo 13, but was exposed to rubella through Duke, at that time on the backup crew for Apollo 13, who had caught it from one of his children. He never contracted the illness, but was nevertheless removed from the crew and replaced by his backup, Jack Swigert, 3 days before the launch. Young, a captain in the United States Navy, had flown on 3 space flights prior to Apollo 16, Gemini 3, Gemini 10, and Apollo 10, which orbited the Moon. One of 19 astronauts selected by NASA in April 1966, Duke had never flown in space before Apollo 16. He served on the support crew of Apollo 10 and was a capsule communicator for Apollo 11. Although not officially announced, the original backup crew consisted of Fred W. Hayes, William R. Pogg and Gerald P. Carr, who were targeted for the prime crew assignment on Apollo 19. However, after the cancellations of Apollos 18 and 19 were finalized in September 1970, this crew would not rotate to a lunar mission as planned. Subsequently, Rusa and Mitchell were recycled to serve as members of the backup crew after returning from Apollo 14, while Pogg and Carr were reassigned to the Skylab program where they flew on Skylab 4. The insignia of Apollo 16 is dominated by a rendering of an American eagle and a red, white, and blue shield, representing the people of the United States, over a gray background representing the lunar surface. Overlaying the shield is a gold NASA vector, orbiting the Moon. On its gold-outlined blue border, there are 16 stars, representing the mission number, and the names of the crew members: Young, Mattingly, Duke. The insignia was designed from ideas originally submitted by the crew of the mission. Apollo 16 was the second of the Apollo-type J missions, featuring the use of the lunar roving vehicle, increased scientific capability, and lunar surface stays of 3 days. As Apollo 16 was the penultimate mission in the Apollo program and there was no new hardware or procedures to test on the lunar surface, the last 2 missions presented opportunities for astronauts to clear up some uncertainties in understanding the Moon's properties. Although previous Apollo expeditions, including Apollo 14 and Apollo 15, obtained samples of premier lunar material, before lava began to upwell from the Moon's interior and flood the low areas and basins, none had actually visited the lunar highlands. Apollo 14 had visited and sampled a ridge of material that had been ejected by the impact that created the Mare Imbrium impact basin. Likewise, Apollo 15 had also sampled material in the region of Imbrium, visiting the basin's edge. There remained the possibility, because the Apollo 14 and Apollo 15 landing sites were closely associated with the Imbrium basin, that different geologic processes were prevalent in areas of the lunar highlands far from Mare Imbrium. Several members of the scientific community remarked that the central lunar highlands resembled regions on Earth that were created by volcanic processes and hypothesized the same might be true on the Moon. They had hoped that scientific output from the Apollo 16 mission would provide an answer. 2 locations on the Moon were given primary consideration for exploration by the Apollo 16 expedition: the Descartes Highlands region west of Mare Nectaris and the crater Alphonsus. At Descartes, the Cayley and Descartes formations were the primary areas of interest in that scientists suspected, based on telescopic and orbital imagery, that the terrain found there was formed by magma more viscous than that which formed the lunar maria. The Cayley formation's age was approximated to be about the same as Mare Imbrium based on the local frequency of impact craters. The considerable distance between the Descartes site and previous Apollo landing sites would be beneficial for the network of geophysical instruments, portions of which were deployed on each Apollo expedition beginning with Apollo 12. At the Alphonsus, 3 scientific objectives were determined to be of primary interest and paramount importance: the possibility of old, pre-Imbrium impact material from within the crater's wall, the composition of the crater's interior, and the possibility of past volcanic activity on the floor of the crater at several smaller dark halo craters. Geologists feared, however, that samples obtained from the crater might have been contaminated by the Imbrium impact, thus preventing Apollo 16 from obtaining samples of pre-Imbrium material. There also remained the distinct possibility that this objective had already been satisfied by the Apollo 14 and Apollo 15 missions, as the Apollo 14 samples had not yet been completely analyzed and samples from Apollo 15 had not yet been obtained. It was decided to target the Apollo 16 mission for the Descartes site. Following the decision, the Alphonsus site was considered the most likely candidate for Apollo 17, but was eventually rejected. With the assistance of orbital photography obtained on the Apollo 14 mission, the Descartes site was determined to be safe enough for a manned landing. The specific landing site was between 2 young impact craters, North Ray and South Ray craters 1,680 m in diameter, respectively, which provided natural drill holes which penetrated through the lunar regolith at the site, thus leaving exposed bedrock that could be sampled by the crew. After selecting the landing site for Apollo 16, sampling the Descartes and Cayley formations, 2 geologic units of the lunar highlands, was determined by mission planners to be the primary sampling interest of the mission. It was these formations that the scientific community widely suspected were formed by lunar volcanism, but this hypothesis was proven incorrect by the composition of lunar samples from the mission. In preparing for their mission, in addition to the usual Apollo spacecraft training, Young and Duke, along with backup commander Fred Hayes, underwent an extensive geological training program that included several field trips to introduce them to concepts and techniques they would use in analyzing features and collecting samples on the lunar surface. During these trips, they visited and provided scientific descriptions of geologic features they were likely to encounter. In July 1971, they visited Sudbury, Ontario, Canada for geology training exercises, the first time U.S. astronauts did so. Geologists chose the area because of a 60 mi wide crater created about 1.8 billion years ago by a large meteorite. The Sudbury Basin shows evidence of shatter cone geology, familiarizing the Apollo crew with geologic evidence of a meteor impact. During the training exercises, the astronauts did not wear space suits, but carried radio equipment to converse with each other and scientist astronaut Anthony W. England, practicing procedures they would use on the lunar surface. In addition to the field geology training, Young and Duke also trained to use their EVA space suits, adapt to the reduced lunar gravity, collect samples, and drive the lunar roving vehicle. They also received survival training and preparation for other technical aspects of the mission. Command Module pilot Mattingly also received training in recognizing geological features from orbit by flying over the field areas in an airplane, and trained to operate the scientific instrument module from lunar orbit. The launch of Apollo 16 was delayed 1 month from March 17 to April 16. This was the first launch delay in the Apollo program due to a technical problem. During the delay, the spacesuits, a spacecraft separation mechanism and batteries in the lunar module were modified and tested. There were concerns that the explosive mechanism designed to separate the docking ring from the command module would not create enough pressure to completely sever the ring. This, along with a dexterity issue in Young's spacesuit and fluctuations in the capacity of the lunar module batteries, required investigation and troubleshooting. In January 1972, 3 months before the planned April launch date, a fuel tank in the command module was accidentally damaged during a routine test. The rocket was returned to the vertical assembly building and the fuel tank replaced, and the rocket returned to the launch pad in February in time for the scheduled launch. The official mission countdown began on Monday, April 10, 1972, at 8:30 a.m., 6 days before the launch. At this point the Saturn V rocket's 3 stages were powered up and drinking water was pumped into the spacecraft. As the countdown began, the crew of Apollo 16 was participating in final training exercises in anticipation of a launch on April 16. The astronauts underwent their final pre-flight physical examination on April 11. On April 15, liquid hydrogen and liquid oxygen propellants were pumped into the spacecraft, while the astronauts rested in anticipation of their launch the next day. The Apollo 16 mission launched from the Kennedy Space Center in Florida at 12:54 PM EST on April 16, 1972. The launch was nominal. The crew experienced vibration similar to that of previous crews. The first and second stages of the Saturn V rocket performed nominally. The spacecraft entered orbit around Earth just under 12 minutes after liftoff. After reaching orbit, the crew spent time adapting to the zero-gravity environment and preparing the spacecraft for trans-lunar injection, the burn of the third-stage rocket that would propel them to the Moon. In Earth orbit, the crew faced minor technical issues, including a potential problem with the environmental control system and the SIVB third stage's attitude control system, but eventually resolved or compensated for them as they prepared to depart towards the Moon. After 2 orbits, the rocket's third stage reignited for just over 5 minutes, propelling the craft towards the Moon at about 22,000 mph. 6 minutes after the burn of the SIVB, the command and service module, containing the crew, separated from the rocket and traveled for 15 m before turning around and retrieving the lunar module from inside the expended rocket stage. The maneuver, known as transposition, went smoothly and the LM was extracted from the SIVB. Following transposition and docking, the crew noticed the exterior surface of the lunar module was giving off particles from a spot where the LM skin appeared torn or shredded. At one point, Duke estimated they were seeing about 5 to 10 particles per second. The crew entered the lunar module through the docking tunnel connecting it with the command module to inspect its systems, at which time they did not spot any major issues. Once on course towards the Moon, the crew put the spacecraft into a rotisserie barbecue mode in which the craft rotated along its long axis 3 times per hour to ensure even heat distribution about the spacecraft from the Sunday. After further preparing the craft for the voyage, the crew began the first sleep period of the mission just under 15 hours after launch. By the time Mission Control issued the wake-up call to the crew for Flight Day 2, the spacecraft was about 98,000 nautical miles away from the Earth, traveling at about 5,322 feet/s. As it was not due to arrive in lunar orbit until Flight Day 4, Flight Days 2 and 3 were largely preparatory days, consisting of spacecraft maintenance and scientific research. On Day 2, the crew performed an electrophoresis experiment, also performed on Apollo 14, in which they attempted to prove the higher purity of particle migrations in the zero-gravity environment. The remainder of Day 2 included a 2-second mid-course correction burn performed by the CSM's Service Propulsion System engine to tweak the spacecraft's trajectory. Later in the day, the astronauts entered the lunar module for the second time in the mission to further inspect the landing craft's systems. The crew reported they had observed additional paint peeling from a portion of the LM's outer aluminum skin. Despite this, the crew discovered that the spacecraft's systems were performing nominally. Following the LM inspection, the crew reviewed checklists and procedures for the following days in anticipation of their arrival and the lunar orbit insertion burn. Command Module pilot Mattingly reported a gimbal lock warning light, indicating the craft was not reporting an attitude. Mattingly alleviated this by realigning the guidance system using the Sun and Moon. At the end of Day 2, Apollo 16 was about 140,000 nautical miles away from Earth. At the beginning of Day 3, the spacecraft was about 157,000 nautical miles away from the Earth. The velocity of the craft steadily decreased, as it had not yet reached the lunar sphere of gravitational influence. The early part of Day 3 was largely housekeeping, spacecraft maintenance, and exchanging status reports with Mission Control in Houston. The crew performed the Apollo Light Flash Experiment, or ALFMD, to investigate light flashes that were seen by the astronauts when the spacecraft was dark, regardless of whether or not their eyes were open, on Apollo lunar flights. This was thought to be caused by the penetration of the eye by cosmic ray particles. During the second half of the day, Young and Duke again entered the lunar module to power it up and check its systems, and perform housekeeping tasks in preparation for lunar landing. The systems were found to be functioning as expected. Following this, the crew donned their spacesuits and rehearsed procedures that would be used on landing day. Just before the end of Flight Day 3 at 59 hours, 19 minutes, 45 seconds after liftoff, while 178,673 nautical miles from the Earth and 33,821 nautical miles from the Moon, the spacecraft's velocity began increasing as it accelerated towards the Moon after entering the lunar sphere of influence. After waking up on Flight Day 4, the crew began preparations for the maneuver that would break the spacecraft into orbit around the Moon, or lunar orbit insertion. At a distance of 11,142 nautical miles from the Moon, the scientific instrument module bay cover was jettisoned. At just over 74 hours into the mission, the spacecraft passed behind the Moon, losing direct contact with Mission Control. While over the far side of the Moon, the CSM's Service Propulsion System engine burned for 6 minutes and 15 seconds, breaking the spacecraft into an orbit around the Moon with a low point of 58.3 and a high point of 170.4 nautical miles. After entering lunar orbit, the crew began preparations for the descent orbit insertion maneuver to further modify the spacecraft's orbital trajectory. The maneuver was successful, decreasing the craft's perisynthion to 10.7 nautical miles. The remainder of Flight Day 4 was spent making observations and preparing for activation of the lunar module, undocking, and landing the next day. The crew continued preparing for lunar module activation and undocking shortly after waking up to begin Flight Day 5. The boom that extended the mass spectrometer out from the CSM's Scientific Instruments bay was stuck in a semi-deployed position. It was decided that Young and Duke would visually inspect the boom after undocking from the CSM in the LM. They entered the LM for activation and checkout of the spacecraft's systems. Despite entering the LM 40 minutes ahead of schedule, they completed preparations only 10 minutes early due to numerous delays in the process. With the preparations finished, they undocked in the LM Orion from Mattingly in the CSM Casper 96 hours, 13 minutes, 13 seconds into the mission. For the rest of the two crafts' passes over the near side of the Moon, Mattingly prepared to shift Casper to a circular orbit while Young and Duke prepared Orion for the descent to the lunar surface. At this point, during tests of the CSM's steerable rocket engine in preparation for the burn to modify the craft's orbit, a malfunction occurred in the engine's backup system. According to mission rules, Orion would have then redocked with Casper, in case Mission Control decided to abort the landing and use the lunar module's engines for the return trip to Earth. After several hours of analysis, however, mission controllers determined that the malfunction could be worked around and Young and Duke could proceed with the landing. As a result of this, powered descent to the lunar surface began about 6 hours behind schedule. Because of the delay, Young and Duke began their descent to the surface at an altitude higher than that of any previous mission, at 20.1 kilometers. At an altitude of about 4,000 m, Young was able to view the landing site in its entirety. Throttle down of the LM's landing engine occurred on time and the spacecraft tilted forward to its landing orientation at an altitude of 2,200 m. The LM landed 270 m north and 60 m west of the planned landing site at 104 hours, 29 minutes, and 35 seconds into the mission at 2 hours 23 minutes and 35 seconds UTC on April 21. After landing, Young and Duke began powering down some of the LM systems to conserve battery power. Upon completing their initial adjustments, the pair configured Orion for their 3-day stay on the lunar surface, removed their spacesuits and took initial geological observations of the immediate landing site. They then settled down for their first meal on the surface. After eating, they configured the cabin for their first sleep period on the Moon. The landing delay caused by the malfunction in the CSM's main engine necessitated significant modifications to the mission schedule. Apollo 16 would spend one less day in lunar orbit after surface exploration had been completed to afford the crew contingency time to compensate for any further problems and to conserve expendables. In order to improve Young's and Duke's sleep schedule, the third and final moonwalk of the mission was trimmed from 7 hours to 5. The next morning, flight day 5, Young and Duke ate breakfast and began preparations for the first extravehicular activity, or moonwalk. After the pair donned and pressurized their spacesuits and depressurized the lunar module cabin, Young climbed out onto the porch of the LM, a small platform above the ladder. Duke handed Young a jettison bag full of trash to dispose of on the surface. Young then lowered the equipment transfer bag, containing equipment for use during the EVA, to the surface. Young descended the ladder and, upon setting foot on the lunar surface, became the 9th human to walk on the Moon. Upon stepping onto the surface, Young expressed his sentiments about being there you are, mysterious and unknown Descartes. Highland Plains. Apollo 16 is gonna change your image. I'm sure glad they got ol' Brer Rabbit, here, back in the briar patch where he belongs. Duke soon descended the ladder and joined Young on the surface, becoming the 10th and youngest human to walk on the Moon, at age 36. After setting foot on the lunar surface, Duke expressed his excitement, commenting, "Fantastic. Oh, that first foot on the lunar surface is super, Tony." The pair's first task of the moonwalk was to unload the lunar roving vehicle, the far ultraviolet camera/spectrograph, and other equipment, from the lunar module. This was done without problems. On first driving the lunar rover, Young discovered that the rear steering was not working. He alerted Mission Control to the problem before setting up the television camera and planting the flag of the United States with Duke. The day's next task was to deploy the Apollo Lunar Surface Experiments package, while they were parking the lunar rover, on which the TV camera was mounted, to observe the deployment. The rear steering began functioning without explanation. While deploying a heat flow experiment, a cable was inadvertently snapped after getting caught around Young's foot. After ALSEP deployment, they collected samples in the vicinity. About 4 hours after the beginning of EVA 1, they mounted the lunar rover and drove to the first geologic stop, Plum Crater, a 36 m wide crater on the rim of Flag Crater, about 240 m across. There, at a distance of 1.4 km from the LM, they sampled material from the vicinity of Flag Crater, which scientists believed penetrated through the upper regolith layer to the underlying Cayley Formation. It was there that Duke retrieved, at the request of Mission Control, the largest rock returned by an Apollo mission, a breccia nicknamed Big Muley after mission geology principal investigator William R. Muehlberger. The next stop of the day was Buster Crater, about 1.6 km from the LM. There, Duke took pictures of Stone Mountain and South Ray Crater while Young deployed a magnetic field experiment. At that point, scientists began to reconsider their pre-mission hypothesis that Descartes had been the setting of ancient volcanic activity, as the two astronauts had yet to find any volcanic material. Following their stop at Buster, Young did a demonstration drive of the lunar rover while Duke filmed with a 16mm movie camera. After completing more tasks at the ALSEP, they returned to the LM to close out the moonwalk. They re-entered the LM 7 hours, 6 minutes, and 56 seconds after the start of the EVA. Once inside, they pressurized the LM cabin, went through a half-hour briefing with scientists in Mission Control, and configured the cabin for the sleep period. Shortly after waking up on the morning of Flight Day 6, 3.5 minutes early, they discussed with Mission Control in Houston the day's timeline of events. The second lunar excursion's primary objective was to visit Stone Mountain to climb up the slope of about 20 degrees to reach a cluster of 5 craters known as Cinco craters. After preparations for the day's moonwalk were completed, the astronauts climbed out of the lunar module. After departing the immediate landing site in the lunar rover, they arrived at the day's first destination, the Cinco craters, 3.8 km from the LM. At 152 m above the valley floor, the pair were at the highest elevation above the LM of any Apollo mission. After marveling at the view from the side of Stone Mountain, which Duke described as spectacular, the astronauts gathered samples in the vicinity. After spending 54 minutes on the slope, they climbed aboard the lunar rover en route to the day's second stop, Station 5, a crater 20 m across. There, they hoped to find Descartes material that had not been contaminated by ejecta from South Ray Crater, a large crater south of the landing site. The samples they collected there, although their origin is still not certain, are, according to geologist Don Wilhelms, a reasonable bet to be Descartes. The next stop, Station 6, was a 10 m wide blocky crater, where the astronauts believed they could sample the Cayley Formation as evidenced by the firmer soil found there. Bypassing Station 7 to save time, they arrived at Station 8 on the lower flank of Stone Mountain, where they sampled material on a ray from South Ray Crater for about an hour. There, they collected black and white breccias and smaller, crystalline rocks rich in plagioclase. At Station 9, an area known as the vacant lot, which was believed to be free of ejecta from South Ray, they spent about 40 minutes gathering samples. 25 minutes after departing Station 9, they arrived at the final stop of the day, halfway between the ALSEP site and the LM. There, they dug a double core and conducted several penetrometer tests along a line stretching 50 m east of the ALSEP. At the request of Young and Duke, the moonwalk was extended by 10 minutes. After returning to the LM to wrap up the second lunar excursion, they climbed back inside the landing craft's cabin, sealing and pressurizing the interior after 7 hours, 23 minutes, and 26 seconds of EVA time, breaking a record that had been set on Apollo 15. After eating a meal and proceeding with a debriefing on the day's activities with Mission Control, they reconfigured the LM cabin and prepared for the sleep period. Flight Day 7 was their third and final day on the lunar surface, returning to orbit to rejoin Mattingly in the CSM following the day's moonwalk. During the third and final lunar excursion, they were to explore North Ray Crater, the largest of any of the craters any Apollo expedition had visited. After exiting Orion, the pair drove the lunar rover 0.8 km away from the LM before adjusting their heading to travel 1.4 km to North Ray Crater. The drive was smoother than that of the previous day, as the craters were shallower and boulders were less abundant north of the immediate landing site. After passing Palmetto Crater, boulders gradually became larger and more abundant as they approached North Ray in the lunar rover. Upon arriving at the rim of North Ray Crater, they were 4.4 km away from the LM. After their arrival, the duo took photographs of the 1 km wide and 230 m deep crater. They visited a large boulder, taller than a 4-story building, which became known as House Rock. Samples obtained from this boulder delivered the final blow to the pre-mission volcanic hypothesis, proving it incorrect. House Rock had numerous bullet hole-like marks where micrometeoroids from space had impacted the rock. About 1 hour and 22 minutes after arriving, they departed for Station 13, a large boulder field about 0.5 km from North Ray. On the way, they set a lunar speed record, traveling at an estimated 17.1 km per hour downhill. They arrived at a 3 m high boulder, which they called Shadow Rock. Here, they sampled permanently shadowed soil. During this time, Mattingly was preparing the CSM in anticipation of their return approximately 6 hours later. After 3 hours and 6 minutes, they returned to the LM, where they completed several experiments and offloaded the rover. A short distance from the LM, Duke placed a photograph of his family in a United States Air Force commemorative medallion on the surface. Young drove the rover to a point about 90 m east of the LM, known as the VIP site, so its television camera, controlled remotely by Mission Control, could observe Apollo 16's liftoff from the Moon. They then re-entered the LM after a 5-hour and 40-minute final excursion. After pressurizing the LM cabin, the crew began preparing to return to lunar orbit. 8 minutes before departing the lunar surface, Capcom James Irwin notified Young and Duke from Mission Control that they were go for liftoff. 2 minutes before launch, they activated the master arm switch and then the abort stage button, after which they awaited ignition of Orion's ascent stage engine. When the ascent stage ignited, small explosive charges severed the ascent stage from the descent stage and cables connecting the two were severed by a guillotine-like mechanism. 6 minutes after liftoff, at a speed of about 5,000 km per hour, Young and Duke reached lunar orbit. Young and Duke successfully rendezvoused and redocked with Mattingly in the CSM. To minimize the transfer of lunar dust from the LM cabin into the CSM, Young and Duke cleaned the cabin before opening the hatch separating the two spacecraft. After opening the hatch and reuniting with Mattingly, the crew transferred the samples Young and Duke had collected on the surface into the CSM for transfer to Earth. After transfers were completed, the crew would sleep before jettisoning the empty lunar module ascent stage the next day, when it was to be crashed intentionally into the lunar surface. The next day, after final checks were completed, the expended LM ascent stage was jettisoned. Because of a failure by the crew to activate a certain switch in the LM before sealing it off, it initially tumbled after separation and did not execute the rocket burn necessary for the craft's intentional deorbit. The ascent stage eventually crashed into the lunar surface nearly a year after the mission. The crew's next task, after jettisoning the lunar module ascent stage, was to release a subsatellite into lunar orbit from the CSM's scientific instrument.